Welcome back to the workshop. So we're continuing the build of the electronic lead screw. This is the kit of parts that James Clough from Clough42 developed. I'll put a link to his excellent build series down below. Of course, when I say kit, you still got to adapt it to suit your lathe and build the enclosure and things like that. So what we got done last time was I got the power supply, 5-volt power supply, all the DIN rails on, the microprocessor and a little booster board, and everything's connected up and it looks like that's going to work. So this time I think, before we can go any further on this, we need to have a look at the enclosure itself. So to make life a bit easier, I've taken the door off. We don't need that for now, and we don't need it until it's on the wall, everything's working, and we just fit it right at the end, so it's just getting in the way. So essentially what we need to make next then, there's two kind of ins and outs on this control box. There's the main sort of input and output panel, if you like, down the bottom here. So I need to cut some of that away because this window they supply with you is too small for what I need. And then I think I've decided to put the fan on the top, so I'll need to cut a hole for that as well. So as I mentioned in my last video, last time I ordered one of these, same part number, same company, was off eBay, so maybe that's why. It didn't have this window cut in it, so I was just expecting it to arrive with a blank panel, and then I've made up a kind of panel. I was just cutting a few bits out to make sure that was all going to fit. So this is roughly what I need to put on here. Actually, I've just done some checking recently. I need to make it a little bit wider, but I mean, that's the whole reason for making the paper templates. But essentially, that will then go on there. So I need to cut out a hole that just runs inside where these fixings go, all the way around, so that each of those can be connected through into the panel inside, and then into the control system at the top there. So you can see what I've got laid out here. I have my power supply there, which is going to be this little IEC 10 amp connector, and I went for the one, you can get these soldered terminals as well. I went for the one with the kind of spade terminals on, and they've got the non-return little holes in, so it should clip on and stay on. I'll put a bit of heat shrink around, of course. So that one will go there. Now there'll be an outlet. Oh yeah, here it is. So I've got one of these little cable glands, so that will go there. Because what I'm going to do, I think I mentioned it in the last video, but what will happen is, so I've got my plug, that'll have its fuse in it. That goes into here. It kind of daisy chains out and comes out to the DRO. So when you switch this unit on, the digital readout will feed off this and come on at the same time, or run off the same fuse. It's pretty low current. So that's those two bits, and then you've got all your power, obviously, that we just showed you a minute ago. And then each of these circles represents, I'm going to be going for these are GX16. You can get GX12, which are a bit smaller. Yeah, it's essentially that nominal diameter, so that's 16, or what is that in inches? 5/8, is it? I don't know. Anyway, it's that big. You can get 12 as well, and then there's a bigger one, I think GX20, but 16 is quite a nice, it's manageable. End up with a reasonable chunky connector, but it's not too big because it takes up too much space. So I've gone for the panel mount type this time. On previous projects I've gone for the one where you push it through and put a screw or nut on the back, and there's an anti-rotation feature in there. But I think this will be a bit nicer. So it won't stand up by itself. So those will go all the way along there. So what have we got there then? So we've got this one goes out to the display. This one goes to the encoder. Well, the encoder comes in here. That's out to the servo power, the 48 volts, and then out for the servo signal, so step and direction. I've reserved the idea to maybe have an e-stop on this. Technically, if you e-stop the lathe, then the spindle will stop, so the feed will stop. Contemplating putting some kind of e-stop, so I've reserved space for that, and I'll make a hole, and we can add another GX16 there. And then the flash connector, I think I showed it last time. Yeah, it comes off the microprocessor, so it's the USB connection, USB-B, comes off the microprocessor and goes in there. It makes it easier to flash the microprocessor without having to take it out of here and hook it up to a computer or something like that. So I think that's kind of, oh yeah, and one more thing, which is I've gone for the 60mm fans and 60mm hardware, generally just to get it a little bit smaller. And this has just arrived, and I'll put it up, and clearly I've made that a little bit too small. That's okay, we're just trying it out for now. So the final one will be a little bit larger around here. And then the other thing I was just doing was just checking how that's all going to fit on here. So this will be forward, so I want the power that you plug in towards the front and all the connectors towards the front. So it will sit somewhere about like that. And there is like a reinforcement return flange around there. It looks like we're going to just miss that. And we can probably get it so that we make use of that cutout there So align that up so that the bolt fixing is just inside. So essentially I just need to mark out what this inner square is going to look like onto here and cut that out. Okay, I've just put the template on there, added a little bit on the bottom to make sure we can fit that dust filter on. That looks like it's going to fit quite nicely. So we need a 15mm margin around there to leave so we can put the screws in. Undecided how I'm going to do that. Nut and bolt is possible, but it's a bit fiddly. Riv nuts is possible, but then it will stand off a little bit. This panel's only 2mm thick, so I was going to rebate it so that it would sit flush, but I think at 2mm there probably won't be any material left. The other option is to riv nut it and then have a little foam seal around there, so we push that on, it compresses. So we'll worry about that later, exactly how I'm gonna fix it. The other option, I guess, is some kind of nut plate the other side, which is maybe is bonded in place. Anything to put some threads on, basically. Right, so we'll take this off, mark it 15mm, and that's our cutout, and then we'll get going on it. Okay, mixed news. So the good news is I managed to cut that out. I know that's freehand, but I think that's going to be okay. Bad news, if you can call it that. On the radio, I was just listening to Leonard Skinner Freebird, which is a really long, wonderful song, and I've had to turn that off so we can track progress, otherwise YouTube gets very upset. Anyway, right, next up we need to put a hole in the top for the fan. So you can see I've marked it out. I've drilled a 6mm pilot through there, and these screws screw into a block of wood I've got on the underside. And the idea is to give it something to kind of bite into and hold when I put this tank cutter, circle cutter in here. So it'll make it a bit more rigid and give it something to push against, and hopefully do a cleaner cut, because these are not, these are not super sharp. They're pretty old now, and hopefully that'll do that. And then that will have something like that on the outside, and then the fan unit on the inside, and it'll pull the air out, and keep it cool. Right. Let's see how we get on. Yep, the answer is yes. That was as much fun as it looked. Yeah, it took a while to get through there. The steel's pretty tough on that little, I don't know if it's a bimetal saw. I've had it years. It was from a marketplace, dirt cheap, so can't complain. So we're through. So we'll clean that up, open up these holes, get the fan installed on there, or at least get the cover secured so we know where that's going to go. Let's put the fan on. I think that's okay. Yeah, that would make sense. And then I think we need to move on to making the enclosure, the plate at the bottom, the custom plate, so we can have all the electronics and hook those up internally. Right, let's clean this up and get the fan fitted. Actually, there's one more thing we can do before we start putting things on it, which is drill the 4 holes in the back. So I've already marked those up around the back. Bearing in mind, when the main control board goes in here, I need to be able to get to those holes, so they're quite near the top and the corners, but not too close so you can't get a screwdriver in. So that's when we ultimately come to fix it to the wall using the wall plugs. So makes sense to drill those now, make the mess now, and then we're good to go, aren't we? So we're all clean from then on. Right. I'll clean this up, drill those holes, and then bring you back. Okay, while he's working on that box, I thought we'd can you keep that noise down a bit? Sorry, okay. So I'll just turn the display and the feed on, and then we'll show you what I mean. So I just turn it by hand. You get some kind of reading on there, but basically, it's pretty stable. But if we try and do it, make sure those wires don't get caught through the inverter. Yeah, you can see on there it's jumping around quite a lot. No, it's not very happy. Now, I have tried a few things, so you can see I've disconnected the earth lead there that was earthing this plate. As we ascertained in one of the last videos, the machine is already earthed. This was just an auxiliary because there was an earth power supply, or a mains power supply, sorry, just behind it here, which I'm no longer using. So just in case there was any signals coming through here and interfering, but that didn't really make any difference. I've also tried just moving these wires deliberately near the mains and away from it, no difference. And as you just saw, I've also tried putting the earth from that screen from the encoder into the earth as well. Yeah, nothing's really made a difference, nothing's really influenced it, always jumping around. Just went in to have a bite to eat, thinking, okay, well, the cable I use for the encoder, which is this one down here, is not screened, just something I had. I thought, okay, maybe I've got to put the screening on that, and then I had another thought. Now, it is good practice to use screen cables, ground them at one end, keep all the signals away from the high power, but in this case, the easiest way for interference to get to the control panel or to the electronics down there is directly through the wiring. So I'm just going to try something now and see if that sorts it out, and then I'll decide where to go from there. Okay, so you'll see over here my lathe and the encoder power supply are both coming off that same socket there, and I think the inverter noise is coming back through the mains and through that side. So what we'll do, we'll just plug this in somewhere else via a massive extension lead to the other side of the workshop and see if that fixes it. Now if that does, then that means the main interference is coming through the mains. I'll either have to put a line filter on the lathe or on the ELS side. I'll work something out, but let's prove that that's the point first. Okay, well, it's up and running again, and if I turn it by hand, okay, that's okay. Right, moment of truth. Yeah, that's the one. Okay, that's pretty definitive. It was coming in through the inverter and it was coming down that cable there, so might have to put a filter in or work something out. At least I know what it is now. Right, let's switch that off. Okay, so now I know that works. All we've got to do now is put this in the enclosure. You finished that enclosure yet? I thought you told me to shut up. Come on, back to work. And after all that, here it is. So we've got the cut out at the bottom there for the panel to go in. I've got my holes drilled at the back so I can mount it to the wall, and then I've also done the fan hole at the top there. So actually, if we put it that way around, so the next thing we need to make is the panel that goes in the bottom there. And here's the panel. So I've cut this out just to make sure it's all going to fit okay. So this will be 2mm aluminium. So what we've got here, so we've got the fan for drawing the air in, we've got the power in there for the IEC connector. That's the power that comes back out again to the DRO. I've got our GX16 for the various inputs and outputs, and then this is the USB input connector that goes to the microprocessor, so you can flash it without having to take everything apart again. Right, so I've got this set up on the CNC machine. Let's get machining. So as usual, I exported the CAD file across into Fusion 360, and then I could use the CAM side of that software. So I ended up using a few tools for this. There's a 4mm end mill, 6mm end mill, and then kind of a V or 90-degree engraving bit to do the lettering. So the 4mm was just to make sure I could get in some of the smaller areas and end up with a smaller radius, because some of the parts that need to go in there, I think like the power adapter, the IEC adapter, and things like that, I just wanted to make sure I got some reasonably sharp corners. And then for the bigger stuff, the 6mm, because it's a bit more robust. here it is cleaned up. So I've cleaned up all the edges with the deburring tool, and then ran a little countersink in each of these, or just to clean up those edges, or just a snail countersink. Ran a really light duty bit of sandpaper over it just to clean it all up. And then I've just been measuring these distances to get that all set and mark through the hole positions here where we've got to drill our little holes. Now I was thinking of using rivnets, but of course they sit proud of the surface, so then this whole thing will stand off a bit, and it means, you know, the air would get in there rather than going through the filter, so then I'd have to put a seal around. I did think about rebating these, or putting a little pocket on the underside so that the top of the rivet would sit, sort of stick into that pocket, but you don't end up with very much material. So I'm not going to be taking this on and off very often, so I'm just going to nut and bolt it. So just be a bolt all the way through here and an eye lock on the back. You know, I did think about making a big nut plate, but you know, how complicated do you need to make this? We'll just nut and bolt it. Anyway, that's it cleaned up. So I think what I need to do now is take out some of these tiny little holes here where I can put the GX connectors. So I'll bring in close and you can have a look. So as you can see, I've got it offered up here. So what I think I'll do is clamp this in position and use a transfer punch, fit in there, and that will just mark that, drill that out, nut and bolt this, get it all lined up again, do the same this side, hold those two in position, and then use the transfer punch on the rest, just because it can move when you're marking out multiple holes. So we'll get on to that in a minute. The other thing we've got to do, obviously I didn't have a drill that small, I think it was 2 or 3 millimeter, or I didn't fancy using the CNC machine for that, so I've just marked them out. And that's our GX16 connector. This is the type with a flange, which I think is going to be a bit more robust rather than the ones with kind of collar on and an anti-rotation feature. I found that over time sometimes they can just turn. There's that. We'll just nut and bolt in there, nice and simple. I've got our power one there, which is the little spade terminal type, and the little things that it should lock into to stop it coming out easily. That goes in there, and then yep, the holes line up, so that's good. I haven't got the I can't find the little connector, but anyway, it looks a bit like this. This is some of it. This will be the cable gland, and you can see that when you tighten those, that grips around the cable. So this is a bit of this missing. I need to find that, but anyway, that I kind of go there, and then the fan will go there. Oh, that will give you a bit of an idea. In fact, they come in 2 pieces, so we'll bolt that down first, and then when it's in, then when that's done, the fan will be on the other side, obviously. Oh no, on this one I'm going to put the fan at the top, aren't I? This is just the inlet, yeah. And then we've got our foam, that will clip onto there. Obviously we've got a load of more of those to do, and then our flash socket, which is currently, it's currently on the main board, so we won't get that off. Anyway, looks like that's going to work. So let's open these up, get it all bolted into position, and then we'll bring you back. So I've experimented a little bit here. I've managed to get some M3 little screws in here, so just drilled and tapped these, and then it meant opening up these holes because they were for a 2mm clearance. So they got a 3mm clearance now, and then I've got these 3mm countersunk screws, and that means I've just drilled and tapped these, so I can just screw them in from one side. I haven't got to fiddle around putting a nut and bolt on, so I think that's a bit of a win. The other thing to mention though is that the heads obviously are larger, and I just checked I could definitely get a little plug on there, and then do the retaining nut all the way up, and it's well clear of the head, even though that sticks out a bit more, so that's fine. Now I wanted to make sure I got different number of pins on each one so that I couldn't accidentally connect them wrong, even if that meant having some spare ones if you like. Now the display and the encoder are both 5, and I think I've misordered here, so yeah, I've got a 6 on that one already, which is for the servo, so that needs a 6. The power for the stepper is 2 plus or minus, and then I've got a 3-pin one for some kind of emergency stop function. So I think what I'm going to have to do, even though the pins will be quite small, I'll order a 7-pin one to go in there, and then I'll only use 5 of those, and that will be for the encoder, and then you can't get them connected wrong. So I'll finish off with the e-stop one, and then we'll get the power in. Okay, next we'll do the power connector. This one I've also opened up the holes a bit and then tapped this for M4, I think it was. Again, anytime you can tap into something rather than putting a nut and bolt, I think is a nice way to do it. Okay, and then we've got the inlet. Because our CNC machine those, they've already got clearance, but that's okay, we'll just have to nut and bolt those. So I won't completely do these up because it's all got to come off again so I can engrave those or put the paint in. Okay, that looks like it's going to fit okay. And then the grommet for that cable gland. This is an M20, I don't know what thread it's by. M20 by 1.5 is the thread. Okay, and that will tighten up around the cable. Okay, now I've just checked that's all going to work. That looks okay, so I'll need to strip this down, then I can paint in each of the letters, and then I need to order a 7-pin GX16 to go in there for the encoder. Other than that, I think it's going to work. So we'll strip this down, get it painted, and then bring you back. So as you can see, it's all coming together now. I've got all the lettering done, all painted in. I've got some of the little units all mounted up. I've still got to order that. That'll be a 7-pin GX16, but everything else is in. And as you can see from here, we've also got the control system inside. So that all fits nicely. I've still got to wire in, so I've got to make up a little terminal there to wire the fan in, and all the wiring down there has still got to be wired in as well. Yeah, so I've still got to make all the little terminal connections that go from here onto the board, power. Still got to get those bolts mounted for that fan, cut down and so on. But yeah, we've got the flash USB flash port installed, and it's looking good. So I think that's it for this video. Really pleased with progress. Good to have that finally cut out and starting to come together now. So in the next video we'll wire this up, and then I think we'll look at get it mounted on the wall, and yeah, then take it from there. Okay, as always, thank you very much for watching, and see you next time.